Have you ever stopped to think about what makes literally everything in the universe go? I mean, from a star burning billions of miles away to the phone or computer you're watching this on right now, it all follows a very strict set of rules. And believe it or not, we're all playing a game governed by these rules every single moment of our lives.
This incredible, invisible force is, well, it's everywhere. You can see its effects when you look up at the sky. Giant metal machines just soaring through the air, defying gravity.
You can hear it in the hum of our factories, the places that forge the modern world. It's the power that builds our cities, the steel, the concrete, the whole shebang.
And it's even closer than that. It's right there in your hand, powering the device you're holding. And it's inside you. It's the very same power that's making your heart beat and your brain process what I'm saying.
So what is it? What is this universal currency that makes everything happen? This ability to cause change and to do work? Well, the answer is simple, but it's also profound. It's energy.
Okay, so let's get on the same page. What is energy? In the simplest terms you can imagine, it's just the capacity to do work or make something change. It's the universe's engine, but it kind of comes in two basic flavors.
See, at its most basic level, all energy is either stored up for later, which we call potential energy, or it's in motion, doing stuff, which we call kinetic energy. You can think of it like this. Potential energy is money in the bank, and kinetic energy is the cash you're spending right now.
So, now that we have a feel for what energy is, we need to talk about the rules of the game. And this first rule is a big one. It's officially called the first law of thermodynamics, but I like to call it the you can't win rule. And here's what it means. The total amount of energy in the entire universe is fixed. It's constant. You can't just magically make more of it out of nothing, and you can never, ever truly get rid of it. The only thing you can do is change what form it's in. Let's make this super clear with a simple rock. When that rock is sitting at the top of a hill, it's just loaded with potential energy. As it starts to fall, that stored potential energy turns into the kinetic energy of motion, and then, bam, it hits the ground. But the energy doesn't disappear. Nope, it just transforms again into the sound of the impact and the heat from the friction. The total amount of energy? It's exactly the same from start to finish.
Okay, so if you can't destroy energy, you might be thinking, great, why don't we just build a machine that recycles energy forever? Well, that's where the second rule comes in. I call this one the you can't break even rule.
I mean, think about your morning coffee. It always gets cold if you leave it out, right? But have you ever seen a lukewarm cup of coffee on your desk just suddenly decide to start boiling on its own? Of course not. And that's because of the second law. It tells us that energy has a preferred direction. It's a one-way street, always flowing from a more useful, concentrated form to a less useful, spread-out one. It's really the difference between things that just happen and things you have to make happen. A battery discharging to power your phone. That's a spontaneous, natural process. But to go the other way, to recharge it, you have to force energy back in by plugging it into the wall. The natural flow is always downhill, from order to chaos. Now, there's a word scientists use for this unavoidable slide into disorder. They call it entropy. You can just think of it as the universe's official scorekeeper for messiness. And the key takeaway is this. Every single process that happens on its own increases the total messiness, the entropy of the universe. It's just like your bedroom or your office. It doesn't magically clean itself up, right? It naturally gets messier over time. That is entropy, right there in your daily life. Okay, so this leads us to a really cool and important question. When we're measuring all these energy changes, does it matter how we get from point A to point B? Or is it only about where we start and where we end up? Well, to answer that, we have to recognize that there are two different types of properties we can measure. Some things only care about the start and finish line. Those are called state functions. But other things depend entirely on the journey you took to get there. We call those path functions. The best way to think about this is climbing a mountain. Your change in altitude is a perfect example of a state function. It doesn't matter if you took the long, easy, winding path or climbed straight up a sheer cliff. The difference in height between the base and the summit is exactly the same. All that matters is the destination. But, and this is a huge but, the amount of work you did, the sweat, the calories you burned, oh, that absolutely depends on which path you chose. The hard path required way more work. And it's the same for energy transfers like heat and work. For them, the journey is everything. So, I know this might all seem a little abstract. Entropy, path functions, why should you care? Well, because these rules are not just for scientists in a lab.
Understanding them is absolutely crucial for solving some of the biggest challenges our civilization has ever faced. These laws literally set the boundaries of what is possible. They're the rules of the game for everything from building a more efficient engine for a car to accurately predicting how our planet's climate is going to change.
So, how can knowing these rules actually help us innovate? Well, take a look at this number, $10 million. What if I told you that this represents a massive hidden power source that's flowing underneath a typical city right now?
That's right. That number, $10 million, is the potential energy value we could get from the organic waste in the wastewater of a single city of just 100,000 people per year. It's an incredible resource just waiting for us to apply these rules to efficiently transform that chemical energy into useful power.
And that's really what it all comes down to. Our entire energy future hinges on how well we understand and play by these fundamental rules. You know, they tell us our limits, sure, but they also show us the path forward to some incredible innovations.
So, the rules are set. We know we can't create energy from nothing, and we know we're always going to pay a little entropy tax on the form of disorder. But winning this game isn't about breaking the rules. That's impossible. It's about mastering them. It's about designing smarter, more efficient systems, finding those hidden resources, and using our creativity to build a sustainable future, all within the beautiful, unbreakable laws of the universe. The game is on.